so we're taking a look at this problem here. The range of values of probability of an event. So this is super common. People do this all the time, 0 to 100. What you really mean is 0% to 100%. Right? 1 is 100%. You can have 0% to 100%. If you do 0 to 100, or you can do 0 to 1 if you don't do percents. So decimals, 0 to 1. Percents, 0% to 100%. 100 is not the same. 100 is not the same as 100%. If you think it is, then I will give you, so percents are like cents, right? So if you think it is, then I will give you 100 cents, and you give me $100, and we'll do that over and over again a bunch of times. Right? So percents are not the same thing as regular numbers. Percents are like cents, decimals. So just kind of keep that in mind. So it would be either from 1 to 100, sorry, from 0 to 1, or from 0% to 100%. Great. And then problem, we'll go ahead and do this one because it's here. All right, so problem probability of rolling 2 dice and getting a sum of 9. So sum of 9 is, let's see, this one has a sum of 9, this one, that one, you kind of go diagonally, they're all here. So that's 4 out of, there are 36 of them, there's six options here and 6 options here, so there's 36 total, 4 out of 36. And then let's see, how about a sum greater than 9? So more than 9, that's these guys in here. These are the ones that have a sum larger than 9. So there's 1, 2, 3, 4, 5, 6 of those, 6 out of 36. Good. Questions? Great. Moving on. Complementary events. So now we're moving down your notes to the next thing. How about Zubair, go ahead and read for us.
For complementary events, the complement of an event E, denoted by
E-bar.
E-bar is the set of outcomes in the sample space that are not included in the outcomes of E. Is everything that is not E.
Yep. So the complement is everything that is everything else, basically. Right. So if I added the probability of E plus its complement, I better get 1 or 100%, because remember, this is like that problem we had in on our quiz. Either you're in this group, or this is the rest of it. So if I add the probability of 1 plus the probability of the rest of it, it better equal 100%, everything. So we can also subtract them. For example, let me go ahead and give you this right here. Right, so if the probability that someone likes chocolate is, say, 23%, what's the probability that they don't like chocolate, or it's not chocolate? So you go to an ice cream store and they tell you, hey, the most popular flavor is chocolate. 23% of the world likes chocolate as their favorite flavor. What's the probability that you pick someone and their favorite flavor is not chocolate? Favorite flavor ice cream. What's the probability? Everyone private chat me. Private chat me. Where is my chat? There we go. What's the probability? Don't forget the percent, or do it as a decimal. So I've heard from 6 people. What's the probability that someone's favorite flavor is not chocolate? Okay, 77%. Hopefully you guys are not just blindly copying whoever typed something in earlier. 77%, don't forget the percent. Why? Because either you like chocolate or you don't. It's one or the other. So these two things better add up to 100%. If 23% like chocolate, then 77% better not like chocolate. What's the easy way of doing this, of finding that, is you are all super familiar with money. You've been dealing with money all your lives, so stick with things that are familiar, right? How do you write 23 cents? 0.23, 23 cents, right? So if you buy something for 23 cents, how much change do you expect to get back from $1? You give them $1, they better give you back 77 cents change, right, or 77%. Okay, everybody on board with that part? Those are complements. You add them up, their probabilities better equal 1. We're going to do this problem also, but we'll do it later. Ignore that one. That's next class. All right, so, we skipped a couple things here. My bad. We're going to do this one next. And let me explain to you what's going on.